Okay, we want to talk about end behavior. When we're talking about the end behavior, we're talking about whether the graph is going to go up on both sides, meaning is it going to go off to positive infinity and positive infinity, or is it going to go down on both sides, meaning it'll go to negative infinity and negative infinity? Is it going to start out going down and then going up like it has a positive slope? So it'll go to negative infinity on the left side and positive infinity on the right side. Or will it go like it has a negative slope and start out up on the left and down on the right? So as it goes off to the left, it'll go to negative infinity. It'll go to positive infinity going off to the left, and it'll actually go to negative infinity on the right. Now, a couple of things that we have to look at when we're talking about the end behavior. We have to look at the degree of the polynomial. And when we're talking about the degree of the polynomial, we have to look at which way the polynomial is written. If it is written in factored format, that is, whenever it's written in factored format, that's when we have like f of x is equal to, say, an x plus 2 times an x minus 3 squared times a 2x plus 1 to the third power times an x minus 5. This is factored format. We also might have a g of x is equal to maybe a negative x to the third times a negative x plus 1 squared times an x plus 2 times an x minus 1. Things of this nature. Let's go ahead and do a square on this one. So when we're looking at these in factored format, what we have to do is we have to look at the degrees. And if you need to, go ahead and add an exponent to anything that has an x, anything that has a variable, because the degree is going to be adding up those exponents. So like in this case, our degree is going to be a 1, 2, 3, 4, 5, 6, 7. We are going to add up all of those exponents. So this one we have a degree of 7. In our g of x, we're going to have 3, 4, 5, 6, 7, 8. That's why I added a 2 on the end. So we have an even degree. And the degree, the big thing about the degree is we need to know if it is even or odd. Because if it's even, an even degree will tell us that it's going, our end behavior is going to go in the same direction. So we're either going to go up and up or down and down. So we're going to be going the same directions. An odd degree means we're going in the opposite directions. And I meant to say odd degree. We're going to be going in opposite directions. Now, it doesn't matter if it's in factored format or if it's in standard format. The degree, even versus odd, will tell us these things. But if we're in factored format, we're adding up the exponents. Now, if we are in standard format, to get our degree, and where I'm talking about standard format, that is where everything is already multiplied out. So in this case, we might have h of x is equal to a 3x squared minus 7x to the 6th plus 3x to the 5th, and that's a horrible looking 6. Let's try that again. Plus 2x minus 3, and maybe we have k of x is equal to 8x to the 9th plus a 4x squared plus a 3x to the 4th minus 2. Now you'll notice these are not necessarily in order, descending order. And so I would probably recommend that you put them in descending order, meaning the largest exponent first, because that will help you with leading coefficients later. But when they're in standard format, your degree of your polynomial is actually your largest exponent. So here we're just looking for our largest exponent. And so the degree on h of x is just going to be 6. Because if you think about it, this one's already multiplied out. Whereas these, we would have to multiply them out. So if you were to multiply these that are in factored format out, you would end up with an x to the 8th or an x to the 7th. Whereas these are already multiplied out. And so here we have a degree of 9. Once you determine your degrees, then that's going to tell you whether you're going in the same direction or opposite directions. What happens then is you need to look at the leading coefficient. The leading coefficient, and really, you just really need to look at the leading coefficient sign. Leading coefficient sign will tell you the direction of the right side of the graph. So, if the leading coefficient is positive, then the right side of my graph is going to be going up. If the leading coefficient is negative, the right side of my graph is going to be going down. Now, what's happening on the other side depends on if the degree is even or odd. So let's say that the degree is even, then this one would be going up and up, whereas this one would be going down and down. If the degree is odd, the right side would still be going up, but the left side would be going down. This one would be going down, whereas the right side would be going up. So we'd be going opposite directions. So let's look at these up here. And I kind of put in some numbers here. When you're looking at the factored format, you look at the signs of the x's, all the x's put together. So like positive, 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 we have a positive. So our leading coefficient would be positive. So we have a degree of 7 and a leading coefficient that's positive. So that means that we would be going up on the right. So we have an odd degree, so we'd be going down on the left. Positive tells me I'm going up on the right. The 7, because it's odd, tells me I'm going the opposite direction. Now looking at the g of x, notice I have a negative, and then here I have a negative, but notice it is squared, and then I have a positive, and I have a positive that is squared. So a positive squared is positive times a positive. So those are just going to kind of cancel each other out. Those are positive. A negative squared actually becomes a positive, and then I have this negative sitting out front. So my leading coefficient is going to be a negative overall. So you have to pay attention to this, but don't just say, okay, this is negative times negative. You have to pay attention to this as negative squared. So that negative times negative actually becomes positive here. Now, since my leading coefficient is negative, that means it's going to be going down on the right side. Since my degree is even, that means I'm going to also be going down on the left side. Let's look at these in standard format. And I'm going to get a different color. So this one is a degree of 6. So what I'm going to do is I'm not going to take this as my leading coefficient. I'm going to look for the term that has my largest exponent, whatever I went with my degree. And so this is going to determine, this term right here determines my leading coefficient. So in this case, my leading coefficient is negative. So that means I'm going down on the right. My degree is odd. Oh, no, sorry. My degree is even. So that means I'm going the same direction. Now here, my leading coefficient is going to be this 8. So my leading coefficient is positive, which means I'm going to be going up on the right. My degree is odd, so I'll be going down on the left. So you're looking at the sign of the leading coefficient determines your right side of your graph. Then the degree, whether it's even or odd, is going to determine your left side of your graph.